Hello everyone, I'm Alex Verzun and I'm here to present my summer research for wireless power transfer optimization. My mentor was Alexander Krasnok and I was part of Photonix initiative in summer 2020. Studies have been conducted on expansion of knowledge of wireless power transfer technology. Currently, WPT is widely used for charging low capacity batteries. But now in 2020, WPT is not used for bigger batteries. With spike of personal electric vehicles in recent years, there is clear need for more powerful systems, while developing new technology is not limited to electrical vehicles. We have supercharger from Tesla and we have battery swapping from Chinese automaker NIO, and both of them works pretty well. But the thing that these technologies is not interchangeable. They're very different. They're different in terms of level of infrastructure they need, in terms of cost, and in other categories. Induction power transfer is a transfer of electrical energy, which is done by generating time-varying electromagnetic fields in the transmitter and extracting power from this field in a receiver to supply electrical load. Advantages of WPT is high data infrastructure and no need for wires, which can be used by ride-sharing companies, and it would increase the efficiency a lot. Methods I used in this research. First, I confirmed the results of previous research. Then I plugged formulas into software and determined the most valuable parameters. Then I created visualization tool to see and understand better how it works, and I will show it on next slide. And I hope that in the future I will be able to check all of these results in microwave lab. So my results is partially written WPT calculator and new formulated study for automatically adaptive load. We are looking at result of simulation in Mathematica. We have two plots, instant power and efficiency is a function of coupling coefficient. We're changing coupling coefficient, capacitance of both sides, and resistive load. This will explain why we need adaptive load. Dashed line is for most efficient adaptive load, but it's not what we need. We need a little different thing. When we change K, the power transfer changes dramatically. And with small k, in this example, it's up to 0.3. We have very small efficiency, less than 70%. And with bigger k, we have very small power transfer, but high efficiency. What we need to do is to find and create a device that would adapt load with a certain level of efficiency, but which would look for maximum power transfer. For example, in here, if we have coupling coefficient as 0.4, we can see that we have 80% of efficiency and 1 watt of average power transfer. But if our K increase, and it depends on distance between receiver and transmitter, if let's say it goes to 0.8, so it's doubles, our power transfer is less than 0.3 watt. But if we can change resistive load, we can move back it up to 1 watt. And accordingly, we will change resistive load on second graph. And now we can see that our efficiency is still 80%, and we get same amount of power transfer. Power is proportional to square of voltage, and therefore we can scale output power by increasing voltage as long as the system can hold the current passing through it. In this example, we have 1 volt of input and we have 425 watts of an output. And if we increase our input voltage from 1 to 16, we will see that our output power is also increased by a factor of 256. Pay attention to y-axis. Now our output power is 1050, which is quite significant, and you can charge a small motorcycle with that amount of power. What we can conclude is that wireless power transfer is currently underrated, and there are many business opportunities with use of it, and also generally theoretical study of WPT is only gate to technology. Lab work is required to determine all limitations, because the circuit we saw on previous slides is idealistic. We don't have ideal source, we don't have pure resistive load, and even if we have this resistive load, we still need to have full bridge rectifier to get DC voltage out of it. Also, this research inspired me to move to the end of the circuit with this idea of creating adaptive load, which I explained on previous slide, and it should be presetted to certain minimum efficiency, and we should look for maximum power transfer. My prime references were resonators for wireless power transfer systems and the coupling coefficient measurement method with simple procedures using two-port network analyzer for multi-coil WPT system. And that's it in here. And thank you very much for participating. Bye bye.